welcome back to Serah's Computer Sessions. This video will be a continuation of the last video. I will be teaching you the 3 features of algorithms. Still, I will not be taking algorithms in detail. So let's move on to the video and check to see what I have to tell you today. Okay, we are dealing with algorithms. In the last video, I had given a brief introduction on algorithm and a simple example to show how to formulate an algorithm. Here we will see the main 3 features of an algorithm. They are sequence, decision, and third one, repetition. Okay, almost all the problems for which we write algorithms will be in a sequenced manner. The steps will be in a sequenced manner. And decision and repetition appears as and when required in a problem. Okay, so to put forward an example, a real life example to demonstrate a sequence, decision and repetition, I think it would be better to take driving as an example that I had already mentioned in my first video along with the definition of program. Okay, so when you drive from one place to a destination point, you will be taking on each and every step as a sequence, right? From starting the vehicle, changing the position from the parking position and starting to drive until we reached your destination, everything will be under a sequence, in a sequence. Speaking about decision, suppose if when you're driving, while you're driving through a road, if you hear an ambulance coming from your back side, you'll soon shift your vehicle to make way for the ambulance, right? It is a decision being made. Okay. Another example for decision is if you are about to face an accident, you will try your maximum to avoid what is going to happen. You know, the decision is taken very suddenly what to do. Okay, so that is about decision. And the next feature is repetition. What can I say about repetition? Okay, this is an example about repetition. Like if you have to park your vehicle in one place and you find that there is no place for parking, some of you, even at least some of you, will be doing what I'm going to say now. You will be in the vehicle, you will drive for a while, you come back, you will go and turn from an island, you'll come back and see whether there is any parking slot available there. It usually happens when you are about to park a vehicle in front of a crowded margin free or a shopping mall, etc. Okay, so these are the this is the example that I can put forward wherein which sequence, decision and repetition come in our daily life. Now let's see what a sequence is in an algorithm. When you write algorithm stepwise, sequence refers to nothing but like doing the actions, executing the steps one by one. Do action 1, action 2 until you reach the stop statement, and that will be action n. Okay, moving on to decision. When you have to decide something, when you write an algorithm, decide something to solve a problem, you can use the if statement. Like if a condition is true, then do a series of actions, else do another series of actions. This if statement, if then else statements also like they also come in programming, where I will be dealing with it in detail, don't worry. But just understand that decisions, if decisions have to be taken while solving a problem and you write an algorithm, you can use if statements. If, and you can check, you can use if and check conditions. Like I will give you an example, you will understand it better then. The next one is repetition. It's like if a condition, like while a condition is true, you have to repeat the steps from 1 to n. You can use while is one of the statements that can be used for repetition. There are other statements used in programming for repetition. We'll be dealing with it when I teach programming. Okay, next we'll move on to examples. The first example is for the sequence feature. This one we have seen in the last video, to add 2 numbers. I've given a name here as calculate sum. In this algorithm, you cannot see any decision making statements, any repetition statements. It just has sequence. It starts from line number 1 and goes forward to end in line number 6. Okay. Next, we'll see an algorithm which includes decision making steps. The algorithm to accept two numbers as input and to either display the greatest number or to print that they are equal. See, you have to accept two numbers as input. Then you have to compare the numbers and check to see whether one is greater than the other. Okay, and you have to print so and so. So let's see. The features used here or features that comes in this algorithm is sequence and decision. Decision, it involves comparison here. The data required are two numbers which can be entered as input, and you can explain that the procedure is comparison that is performed and a decision that has to be made. Then you will have an output, and that is a display message. Okay, we'll move on to the algorithm. I have given the name as find greatest, and here I've written the features as sequence and decision. There is no need to write the features when you write algorithms. Just for your understanding, I have included that. So let's start the algorithm. First is the start statement. Then you need two numbers. So you have to input two numbers. In the last video also, I had mentioned that we should include a print statement and enter two numbers. If you did not watch my last video, you can go back and watch my last video and come to this video. So after inputting two numbers, we start to compare the numbers. Okay, if A is greater than B, then what should you print? A is greater than B. And if B is greater than A, then you have to display a message as B is greater than A. If A is equal to B, then both A and B are equal. Okay, this is a very simple program which includes only if statement, if then. There is another set of statements like if then else and nested if statements and also there that we will be studying when we will study programming. Okay, then you can stop so that the computer will accept two numbers A and B, compare which one is greater and display the message likewise. Now we'll move on to an algorithm that demonstrates repetition to calculate factorial of a given number. Okay, here I have taken an example to calculate factorial of 5. How will we write the steps in mathematics to calculate a factorial? 1 into 2 into 3 into 4 into 5. It's so simple like this, right? Some people write in the reverse manner, 5 into 4 into 3 into 2 into 1. Both are the same. Okay. So we'll discuss this method today, and we'll find out how to write an algorithm for this particular problem, which includes repetition. Okay, so let's assume that our first step is 1 into 2. We take the first two numbers, we multiply, we get the result. 2 is the result, and this result is used as the input to the next step where we multiply this result 2 into 3. We get 6, right? And this 6 is the result at this particular step. This 6 is used as the input to the next step where we write 6 into 4. We get 24. 24 is used as the input to the next step. 24 into 5 equal to 120. As we have reached 5, we are stopping our calculation. We assume that we got the result. Yes, we have got the original correct result as 120. Okay, now let me write the same thing to my right side. Here you can see that the first column, it indicates the result obtained in the previous step, right? In the second column, you can see that the number increments by 1 at each step. When you proceed stepwise, you can see that 2 is incremented by 1, you get 3. 3 is incremented by 1, you get 4. 4 is incremented by 1, you get 5. But there is a little problem here. See, usually these counter values start from 1. But here it is, here it starts from 2. So let me include one step at the beginning where you get a counter value that starts from 1. There is no change in the calculation. 1 into 1 you get 1, and this result can be used as the input to the next step. So I think you got my point. Now we'll see how an algorithm can be written. I'm giving an a name for the algorithm as find factorial. The features are sequence and repetition. Here, see, I've started the algorithm. I'm asking for the input. Enter the number, input n. Okay, after accepting the number, I can start my calculation. Okay, before starting my calculation, I am assigning value 1 to two variables f and c. Obviously, c you might have understood that it is used for as a counter variable, counter value to increment plus 1 like that. Why is f used here? F is used to store my result. I should display my result, right? So in order to display my result, the result should be assigned to a variable. Then only you can give it in the print statement. So for storing that result as well as for storing the result of each step, I have used the variable f. Okay, now we'll start our while statement. See, for repetition, in the earlier slide itself, I had explained that you can use while statement. So here also I have used while statement. So what was while's format? While a condition is true. So I'm going to check a condition here. What is the condition that I'm going to check? Whether c is less than or equal to n. What is c at this particular instance? C is 1 and n is 5. See, I am going to check my counter variable every time before I multiply to see whether my counter variable has reached 5. Okay, if it has reached 5, then I can stop my procedure. That is the whole concept of this repetition and as well as the condition checking that comes along with the repetition. Okay, so you have to be able to identify what should be the condition that has to be given along with the while statement so that our desired result can be obtained. Okay, here in this case of calculating the factorial, I can use counter as well as the number n. Okay, so I'm checking whether 1 is less than or equal to 5. So the counter, the condition is true. If the condition is true, I can execute the following two statements, which is written between a begin and end construct. Okay, whenever you use a while statement, you will have multiple statements within the while statement to get executed. So to categorize them into a single block, we use begin and end. Always remember to write begin and end statement while you use while statement. Okay, so since the condition is true, we can start executing. The first line is f is 1 into 1. We are multiplying. When we are writing algorithm as well as program, you have to use asterisk symbol instead of the cross symbol. Okay, so in the first case, we multiply 1 into 1, we get the result as 1. So we assign this 1 to the variable f. Okay, now the next step is c equal to 1 plus 1. We are incrementing it. We get to 2 and 2 is assigned to c. So the old value that f and c holds will be overwritten with the new value. Okay, so after calculating c, we can see the end statement. Now as soon as we see the end statement, the control of the algorithm as well as the program gets backtracked or redirected to line number 6 where the while statement lies. And again the while statement will execute and check to see whether the condition is true or false. In this case, in while statement, you will have the new value of c. What is that? 2. Whether 2 is less than or equal to 5. That is the condition that will be checked here. Yes, 2 is less than or equal to 5. So the condition is true and therefore the steps that are inside the while statement will be executed again. So what is that? That is f, calculating new f. What is new f? It is the old f into the new counter value. That is 1 into 2. You get a 2 and the new counter value is 2 plus 1. You get a 3. if you are getting confused while you're watching me, please pause the video and calculate with me so that you'll get to find it easier. Okay. Now we see the end statement. As soon as we see the end statement, the control gets back to line number 6, and that is while, where you will check the new counter value against the number for which we have to find the factorial, and that is 3 less than or equal to 5. Yes, the condition is true. 3 is less than or equal to 5. So what happens? The new f you will get as 2 into 3, and that is equal to 6. 6 is the new value of f. 2 was the old value of f. 3 was the new counter value. Now the new counter value is calculated as 3 plus 1, and that is equal to 4. 4 is assigned to the counter value C. You find the end statement. You go back to while, where while is checked for the checked with the new counter value against the number 5. So 4 is less than or equal to 5. Yes, it's true, right? So you get a new value for f and c. Again, f is calculated 6 into 4 equal to 24, and c is calculated as 4 plus 1 equal to 5. See, here the counter value got to 5. You see the end statement. You go back to while and you check to see whether 5 is less than or equal to 5. Since there is an equal to symbol in that condition, yes, 5 is equal to 5. The condition is true. So one more time, our statements will be executed. I have not included that statements here in the slide because I don't have space actually. So you just calculate on your own. What will be calculated? The new f value, and that will be 24 into 5. And the counter value will become 6. You see the end statement. Again, the control will go back to line number 6, while statement, where what will be checked in while statement? Whether 6 is less than or equal to 5. 6 is not less than or equal to 5, right? So the condition gets false. So as soon as the condition becomes false, automatically the control will be shifted to the line number that is next to the end statement, and that is here the line number 11, wherein which we can find that the command is to print the factorial. So whatever the last value is stored in the factorial variable f, that will be printed here, and the algorithm stops. Okay, I hope that whatever I explained today was easy for you to understand. I'm stopping algorithm class with this session, with this video. If anyone needs more sessions, more parts on algorithm, more examples, please leave me a comment, or you can mail me. I will be taking more sessions if required. Okay, please like, share and subscribe. Thank you. God bless you. Hope to see you soon with the next video.